Hey everyone, welcome to my channel. Um, Today we are going to discuss the material stress, the stress that develops inside a material. So, first we have to understand what is this stress. Now, let us say this is a material, a block of a material. As you know that these materials are made of atoms or molecules, and they are bonded together by means of certain covalent metallic bonds or some ionic bonds. So they have some strength inside them, and thus when we apply some load on them, then then these molecules and atoms, as they are bonded together, will try to resist the load to deformation. Means that when this load is applied, this load tries to deform this object, and these atoms and molecules, due to their molecular strength or atomic strength, will try to resist the deformation. And this resistance offered by the atoms and molecules to deformation is called as stress or material stress. It's simple. Now, depending upon the type of loading, in which direction the loading is done, it can be classified into various types. So let's see what are the types we can see. Before that, to simplify the process, what I had done here is that I just reduced the three-dimensional system, that the box that we have seen in earlier slide, to a two-dimensional system. Now I have also given some nomenclature. Let's say this is the cross section, okay, and this is the axis. This one is the axis of the material. Now when we look from this side, or we take the front view, it can be seen like this. Okay, now this is the axis, this is the axis, this is the axis, and here this will look something like that. And somewhere here is the cross section on which the load may be applied, or we can also apply load here, and depending upon these loadings we will see that what are the types of stress that we have. Now the block that we have reduced to a two-dimensional system, here we can see this is the axis of the tool. Now when we apply the load across the axis, then the stress developed inside the material can be tensile or compressive. Okay, now what is this tensile stress and what is this compressive stress? So first we will see what is tensile stress. Now when we apply a load along the axis, okay, let's say this is the load, that is P, that we have applied, and this load tries to elongate the material or increase the length of the material in the direction of load. Then the stress that is developed inside the material is called as tensile stress. Now when the same load is applied in the opposite direction, that is in a direction that will tend to reduce the length of the block that is under construction, tend to reduce the length, then in that case the stresses that are developed inside the material will be the compressive stresses. And here we are only talking about the primary stress, not any lateral stress. We will discuss in later classes, but primary stress is the stress that is developed by loading along the axis of the material. Okay, now let's see what is shear stress. Now let us assume this is a material. This was the same material what we have assumed earlier. This is a three-dimensional box, and now we apply a load here. Okay, when we apply a load here that is parallel to the face, this load will tend to give an angular deformation to this material, and this angular deformation of the material, or the load that tends to cause angular deformation of the material, results in shear stress. The stress that is developed inside the material will be shear stress. Okay, so this is the stress when the force tends to give a angular tilt or deformation to the material. Now, coming to the mathematical representation of stress, now again we see this box, three-dimensional box. What we have seen earlier is that this is the axis of the box. Okay, now we, depending upon the load where we apply, the stresses are either tensile, compressive, or shear. So when we apply the load along the axis of the box, then the stresses will be either tensile or compressive depending upon the direction. Now when we apply a load parallel to the face, then the stresses that, what we have seen here is that these all the stresses depend upon the area over which they are applied. That is, if they are applied on this cross section, then they are tensile or compressive, or if they are applied parallel to the face of the object or in a direction parallel to this axis, then they are shear. So what you can say about stress? So stress can be mathematically represented as the applied load upon area, and this area will be, what will be this area? This area will be the area on which load is applied. Okay, so this is all about stress, its mathematical expression. In the coming classes we will learn about strain, lateral stresses, and Poisson's ratio, volumetric strains. So stay tuned to the channel and have a good day. Thank you.